Go.
Hello everyone, this is the editorial for LeetCode Biweekly contest number 88. Let's start with question number A. The question was simple. You are given a string. You have to remove one letter from the string and check if the frequency of all the letters in the string are equal. So basically there is an example A, B, C, C. I can just remove C from here and have all the frequency of all the letters are same here. So the answer for this will be true. Similarly, if you go for the last one, the second sample, A, Z, Z. However, if in any way I remove one letter, the frequency of the letters remain different. So the answer for this is false. So we can basically have three cases for it and get the answer accordingly. First case, if simply have one letter multiple times in the string, this is always going to be true. So we've simply written true here. Next, the answer was if we have multiple letters with the same frequency and one with the frequency greater than the others by one, you can simply remove one of them and the frequency remains same for all the letters. It's the second case, and that gives the answer for second case. And the third case was you have all the numbers with multiple frequencies of same frequency and one of them having a frequency of 1. So if we remove that number, there is the frequency becomes 0 for it, and all the other letters have frequency equal. This becomes the third case, which will get true for, and all these three cases together gives true, and all other cases gives false, and that's the solution for number A. I would like to now hand over to Maxwell for question B.
Hello everyone, this is the editorial to the problem longest uploaded prefix. So in this question, we have to make a class in which we will be given a number n, which is the total number of videos, and each video is represented by distinct numbers. And we have to upload the videos in the server, and we have to get the longest uploaded prefix. Now in this question, the uploaded prefix is the range 1 to I. Now, if I dry run in this first example, first we have initialized this, which means that we are given 4 videos. Then we upload 3, and then we ask for the longest. Now, the longest starts from 1, but in our current sequence, 1 is not present. So the answer here would be 0 because there is no longest prefix. Then we uploaded 1, and then we ask for the longest prefix again. The longest prefix starts from 1. So we have 1. Now we will go to 2. But 2 is not present in our sequence yet. So the answer will be 1. Now I upload 2, and then I again call the longest function. Now we have 1. We will go to 2. We have 2. We will go to 3. We have 3. But we do not have 4, which means that the answer would be 3. So this is what we have to do. And my approach, there might be easier approach for this problem, but I will share the one I could think during the contest. Now suppose I have an array A. Let it be one based indexing. Now suppose all the elements in the array were initially 0. Now what I will try to do, my main motto is to count. Suppose I am given 3. My main motto is to count that do I have all values from 1 to 3 present in this array? And if it is, then 3 can be my possible answer. So how will I check that? Suppose initially I am given 2. So I will go to this array and update the 2 pointer by 1. Suppose now I am given 1. So I will just go here and update this to 1. And now I'm given 3. So I will go and update to 3. Now, how will I check if I have 1, 2, and 3 elements present? If the sum of this array is equal to this index, then it means that all the elements are present, and it basically means that we have 1, 2, and 3 present in an array. 3 can be my possible answer. So this was my main intuition behind this problem. So I am given this class. I have started using segment trees. So I will initialize my segment tree with size 10 to the power 5 plus 1 because it is the maximum limit, which basically means that I have an array of 10 to the power 5 elements initially initialized to 0. And now in the upload function, I just update the segment tree with the value given. Like suppose I am given upload 3. So what I will do is I will go to the third index and add 1 to it. And now I have to find the longest. Now how will I find the longest? I will use binary search on this. Like suppose mid is my longest subsequence till now. What I will do is I will check whether the sum from 1 to mid is equal to mid or not. Because as I have shown in this case, like if this sum is equal to this index, which means we have all the elements from 1 to 3. So this is the main logic, that if this sum is equal to mid, then it is my possible answer. So answer will be updated to mid and low will be updated to mid plus 1. If we cannot find the answer, then high is equal to mid minus 1 and then we will return it. So this was the my main iteration. Again, there can be easier methods, but this was the one I could think of in the contest. Now I'll pass to Bhaumik for editorial for question C.
So the question number 3, C, is described as you are given two arrays, num1 and num2. And now you have asked to give the XOR of all the pairings possible for these two arrays. So if you see example number 2, here the num1 is given as 1 and 2, num2 is given as 1 and 3. So all the pairings possible here are 1 with 3, which is this one, 1 with 4, which is this one, 2 with 3, which is this one, and again 2 with 4. These are all the pairings possible, and we have to return the XOR of all these pairings. So now if we write this, expand it, we get 1 XOR 3, XOR 2 XOR 3, XOR 1 XOR 4, XOR 2 XOR 4. So now we can open the brackets. And if we group them, we get 1 XOR 1 for 2 times, then 2 XOR 2 for 2 times, then 3 for 2 times, and 4 for 2 times. If we expand this like this, we can see that we get 3 for exactly 2 times, 4 for exactly 2 times, again 1 for exactly 2 times, and 2 for exactly 2 times. If we do the same for the example 1, we will expand it as follows. We will get 2 for exactly 4 times, 1 for exactly again 4 times, 3 for again 4 times. And similarly, we will get 10 for 3 times, 2 for 3 times, 5 for 3 times, and 0 for 3 times. Right? So now we know that XOR of the same number, even times, we get 0. And so for odd number of times, we get the number itself. So now for this, we have odd nums. Num1 has a length of odd length. So we'll get 10, 2, and 5 when we open it. And we will get XOR of 2, 1, and 3 for even number of times. We'll end up with 0. So we simply have to XOR this thing. 10 XOR 5 XOR 2 XOR 0 will give me 13 as the answer. So now the program was as follows. Solution. If the length of the num1 array is odd, you have to simply find the XOR of all the numbers in array 2. And again, if you have a length of num2 as odd, you have to find the XOR of all the elements in array 1 and simply merge them and return the answer. That was the solution for C. Let's move on to D.
In question number D, we are given two arrays num1 and num2, each of size n, and a parameter diff. Now we have to count the total number of pairs I comma j which satisfy this equalities. I'm going to call this array A and this array B. So we have to find A of I minus A of j less than equal to B of I minus B of j plus j. We have to find the total number of pairs that satisfy this inequality. Now we are given A of I minus A of j equals to B of I minus B of j plus a difference d. Now if I rearrange these terms, we will get A of I minus B of I minus B of j minus B of j which is less than equal to d. Now I am going to call this x1 and this is x2. So our inequality boils down to this. And now I have to solve how many pairs of x1 and x2 are there which satisfy this inequality. Now if you see this expression, our answer depends on ij. So if I create a vector of ai minus bi, then this is one element of that vector and this is another element of our vector. So we don't need to work on two separate vectors. Only one of them will be sufficient, which will consist of a of x minus b of x. So first of all, what I did was I just created this vector, and after that, let me okay, let me take this example. I have 3 comma 1 minus 1 and I have minus 2 comma 2. If I create the vector, it will be 3 minus of minus of 2, it will be 5, and minus of minus 2, it will be 3. Now I have to check how many pairs are there such that the inequality x1 minus x2 is less than equal to the difference. In this case, the difference given is minus 1. So which means x2 is greater than or equal to x1 plus 1, or x1 is less than equal to x2 minus 1. Now, I will start iterating from the last element. This is minus 3. I will assume this is my x2. So what will be the x1 in this case? X1 will be less than equal to minus 3 minus 1, which is equal to 4, minus 4. So I have to find all the elements behind this minus 3 which are less than or equal to minus 4. Like in this case, the answer will be 0 because there is no element less than equal to minus 4. So this was what we have to do. We will start checking from the last element and see how many x1s are there which satisfy the following condition. So if you recall the approach used in question number 2, this is kind of similar, but the only drawback is the constraints. We are given negative numbers also, and to treat them as indices is very difficult. So since the numbers are quite low, 10 to the power 4 is not too big, I will add some x to all the values to make the numbers positive. And by doing so, it will not affect my answer. Because suppose I add a number k to all my possible answers, then I will have x1 plus k minus x2 plus k is less than equal to d. Now this inequality won't be affected because these k's will cancel out. So that is why I added a big number so that I don't have to deal with negative numbers again. So this is what I did. I added plus 5 into 10 power 4 to my ax minus bx to remove the negative indices. So now the approach is kind of similar to question number 2. We just create an empty array and we just create an empty array. Suppose these are the indices. till suppose n or any value x. Then I will keep filling this array with ones. We will keep adding one to the following indices. Like what I did here is I calculated the term, and after that I will go to that index and add one to it. Now I have to calculate how many terms are there which satisfy the inequality. So I will go from the last, and I have to find the terms less than equal to this. So what I will do is just calculate the sum of all the values from 1 to the current value, because that will be my answer. Like suppose I am given that you have to find all the values less than equal to 4. So I will go to this array and I will just add all the counts of the elements still here. Like in this case, 1 plus 0 plus 1 plus 1, 3, which means there are 3 elements which are less than equal to 4. So this was the whole intuition. We will go from the back. I have to check all the values less than equal to this. Then I will query from 0 to value, and I will just add all the answers that I received from here, and then decrease that element. That was the logic behind this. With that, we conclude the case study for this LeetCode's Biweekly round 88. Thank you.